Count me in. Oh, I hear you. Are we good? Okay. Now we're starting our interviews with the teams. These people work very hard, and now we're starting off with University at Buffalo from New York. Howdy, all. Can you hear me? I think they can. I can't hear them, but okay. Oh, there we go. Yes, I hear you guys now. Perfect. Howdy. Let's just get started with the interview, and then after we're done with the interview, we'll show your promo video. Yeah, awesome. Thank you guys for showing up. I know you guys worked very hard. And so let's get into it. Talk about your design. What were the challenges you came up with, and what's the general concept?
So our ride is a new take on a pendulum ride. So our twist on it is that riders will be sent into the flying position while they're on the ride.
Cool.
So you get to fly in circles like you're a superhero.
Oh, wow. Awesome. And so you just go face down and you're able to. How many riders do you have on each pass of the ride?
We have 21 riders on each cycle, and we estimate 2 cycles per minute.
Oh, cool. And what were some things that you learned from designing this model?
We definitely learned a lot about how to actually apply some of the knowledge from our classes to real life problems. And do you want to talk a little bit?
Well, I guess like there's like kind of like a couple of like different things about it. Because I mean, like, well, we did like kind of like encounter like just like a bunch of different problems. I mean, like some of this was like, we had to not only did we like incorporate like some of the things from our classrooms, we had to actually learn a bunch of different fields. Like, because all of us are either mechanical or civil engineering, we never really dealt with Arduinos before, so we had to learn that entire program and come up with like the code for it. We also had to, as Emma was mentioning earlier, use our knowledge from the classroom and apply this to here. And because this is like one of the first times that we're like entering this sort of competition, all of this is brand new. And so no matter what we do, whether we succeed or fail, it all culminates into a very rewarding and a very huge learning experience.
Oh, absolutely. When you say applying stuff that you learned from the classroom to real world and then applying new knowledge you guys had to learn on the fly while building this or while designing this, what do you think about when applying like the safety standards and making sure that it's compliant with our rules and with what we're trying to simulate the real world will be like? Did you guys have any challenges about this?
Yeah, we definitely had some challenges in trying to apply the safety standards, and it was always in the back of our mind whenever we were trying to design a new feature, and we were like, oh wait, hey, that might not be compliant. So it definitely limited some of our ideas in a way.
You got to make sure that the ride's safe in order to have it exist 100%. And so you just kept the idea of making sure it's safe while going along the full design process.
Yeah, exactly.
And then if you guys were to do, I know there's several iterations in your design already, but if you guys were able to code back to the start, and you guys learned a lot from this, but if you were able to go back to the start maybe next year, if you decide to do it again, what would you want to improve? Like when it comes to either like team organization or just general design philosophy?
Well, one of the things that we kind of would want to do is that like we want to like now that we actually have done this and now we know we want to like have like a I guess in a sense like a better schedule, because like one of the things is that like I guess with the combination of like the pandemic and everything going on is that like towards the end there was a bit of like a rush, and also because we haven't really done this before, and so I think one of the biggest things is actually kind of coming up with the schedule. Like now we know that okay, in order to get like like even just for things like the club, like in order to get the POs, and we have to do that like a lot more earlier, and like just a bunch of other like different schematics along with this.
Yeah,
and also all the confirmation bias, like us being a really small group. Whenever one of us had an idea, we kind of there wasn't that much challenge to it, and we only like figured out a huge flaw in our design like really close to the end when someone else came in and told us. So bringing our ideas to more people, introducing and explaining it well,
pitching your ideas and getting input from others.
Yeah.
Okay, amazing.
Yeah, next year we definitely want to try and get more of a variety of students
Okay.
involved in the project. One of our struggles was definitely the fact that none of our team members have much experience at all with control systems or electrical engineering whatsoever. So that was a big problem we encountered.
Yeah, and so you guys want to diversify your team when it comes to majors and skill sets and life experiences, right?
Yeah.
Okay.
Yep, exactly.
Absolutely.
Awesome. Let's see. We still got a couple more minutes before we air your video. I don't know. What are some highlights you guys thought about when either in your ride or just along the path? Any fun stories and stuff alike?
So originally, what we were actually planning on for this ride going to be was that we were planning on having it where instead of starting from the bottom, it was actually going to start from the top, and then unlike normal what's called pirate ship rides, it was
Yeah.
going to actually spin down. It's going to have like a really fast sort of acceleration, then gradually slow down, then like spin all the way back up to get to the
Oh,
top.
okay, yeah.
Yeah. But the problem with that is that one of the requirements for this is that it has to have like a net gain in height of 300 feet. And so this would actually just like, this wouldn't actually work inside of this because we wouldn't actually gaining height. If anything, we'd be losing height.
Yeah. Going in the negative.
Yeah, we also had an idea early on to incorporate an LED panel underneath the curve because the seats would be facing downwards, so they'd be looking down the whole time. So if we
Yeah.
had an LED panel, that would be
Oh, okay.
really interesting for the theming, that it could change all the time pretty
Yeah,
much.
change up the attitude of the ride almost. Awesome. Okay, and thank you guys for coming out. We're about to show your promotional video that you guys made, another requirement. And so thank you guys for the interview, and I hope you do well later on today.
Thank you.
Thank you so much.
Yeah.
Have you ever wanted to fly like a superhero? Have you ever found yourself locked up in an asylum? Well, fear not. We have a solution to both of these problems. Introducing Flight Asylum, a non-stop flight to break out you and all your friends from the asylum. The brand new thrill ride that inverts and oscillates you as you fly to start your new life on the run. Flight Asylum incorporates springs on the back of the seats, which allow you to swing back and forth while the ride is in motion. A truly unique experience. Experience 2 Gs of force as you force your way out of the shackles of your captors, powered by an Arduino and a 12-volt motor gear system. You'll be head over heels over 12 times. You'll soar to heights of over 600 millimeters. Opening this fall, only at UB. But be wary, if you ride for too long, you might just go insane.
Next up for our interviews, we're having University of Nebraska-Lincoln, coming from Lincoln, Nebraska, of course. Can you guys hear us?
Yes, we can hear you.
Awesome.
Awesome. Thank you guys for showing up. I'm from Nebraska. Shout out to Dawson and Kale. I heard they were on your guys' team.
They are.
Yeah, I went to high school with them. It's nice interacting with them again. So let's get on with the interview. So when you guys were designing, when you guys joined this competition and were designing your ride, what were some challenges you guys encountered along the way?
I'd say one of our main challenges was the mechanical design behind how we were going to get our ride to function. We combined the drop tower attraction with like a swinging carousel type ride. So just the mechanical design behind integrating the two into one ride system was a bit of a challenge for us.
Cool.
Why did you decide to go this route with your model? I'm just curious.
I think we decided to not do the model mainly because of time constraints and just the mechanical systems not working as well as we wanted them to. Along with this COVID scheduling, it was kind of hard for us all to meet up together and sadly to build the final model.
Oh yeah, 100%. And so how has COVID affected your guys' design process and making sure that you guys stay safe while also interacting as a team?
Luckily, UNL has allowed us to meet in person. So we've had in-person design meetings pretty much every Wednesday. So we've gotten to hash out our design in person and make those changes we needed to, which has been lucky for us.
Lovely.
Awesome. Is there anything specific you'd like to highlight about what you made?
So our ride concept is called Skydive. As I said earlier, it combines a drop tower and a swinging carousel. So we were really excited about the theming that we got to incorporate into our attraction. We kind of took the sky, like the above, and dive, like down below, and integrated that into our final ride, which has a neat theming to it.
Awesome.
Absolutely. And how would you guys describe the composition of your team? Are you guys mostly mechanical engineers? What are your mix of?
We have a mix of people. Mostly, I guess none of us are the same. So Kylie's an electrical engineer. I'm a chemical engineer. We have a mechanical engineer on the team, and some others. But I say we have a good mix.
Cool. And do you think that improved that input of different ideas, different experiences? Did that improve? How did that affect your design decisions?
It very much did. So one of our team members is also like into set design. And so we got some input from her on like the theming and how that can be incorporated, like using that mechanical model that we did come up with, how our theming could be easily like done for that. And she showed us like a different bunch of ways to do theming, which was nice to have like that aspect besides just the engineering part.
Lovely.
That's really cool.
When it comes to safety standards, a big core of this competition was trying to make models that would somewhat reflect the real world with how we want, with safety standards, making sure that our riders stay safe and making sure everyone is safe, from participants to viewers and stuff. How did you go about that, I guess?
Do you have an answer? Okay. So we obviously use the ASTM F24 standards. We read through those at the start of the competition just to get an overview of what standards would need to be incorporated. Then throughout our design process, we used the risk analysis tool that Advantis provided us.
Nice.
This allowed us to like make the risk and see these are ones we need to combat and overcome. Then we kind of went back, looked through the ASTM standards, said, how can we combat these risks using those standards? And just throughout our design process, they were constantly on our mind.
Yeah.
Was there anything within the standards that you thought was challenging? I myself kind of went through the standards and kind of wrote up that adaptation document. So is there anything that you thought was pretty challenging when it came to the standards?
The standard I always have trouble with is like the gravity ones, like how many G's you can have in like the forward facing direction and all that stuff is a little difficult for my brain to comprehend, but yeah.
Looking forward to next year, or if you guys were to just redo this year, what would you guys change when it comes to design process, team structure, recruiting?
I would just say trying to get more time for us to, I guess, bounce ideas off of each other and just come up with a better, not ride, but come up with more ideas so we can incorporate them all into a better ride and then have time to make those dreams a reality.
Yeah.
I don't really have anything else to add. Do you have any more questions, Nate?
Thank you guys for competing in this competition. I know it's first of time, and I hope you guys come back next year. I wish you guys best of luck for later today, and we're about to start showing your promotional video that you guys submitted to us earlier this year.
Yeah, thank you guys.
Thank you for coming
Thank
out.
you.
next up for interview from Cal Poly San Luis Obispo. Howdy, how are you doing?
Hi there.
Hi, glad to be here.
Well, thanks for coming out. Thanks for participating in the competition. And let's get started with the interview. Tell us about your ride.
So we took inspiration from a flat ride that we were able to research and fell in love with, Skywheel. It was a double Ferris wheel system that rotates around a central axis and creates an experience unlike any other type of Ferris wheel attraction.
Mm-hmm. That's really cool. So what were some of the challenges you guys had with designing your model? Or I guess since you kind of took inspiration from the Skywheel, you kind of knew how it worked already, but what were some challenges for you guys?
So while we did take inspiration from that model, all of the kind of design work and all of that stuff kind of came directly from us. We knew what we wanted the ride to look like, but that was kind of the only inspiration we drew from that. The challenges that we had, though, were we are mostly a team of very young engineers.
Mm-hmm.
Out of our members, I think 4 who are past their second year.
Mm-hmm.
So when we came into this competition, we came in with the knowledge that we were going to have to kind of bring up a group of engineering students up to speed to, a second and third level design curriculum from the beginning. So that was kind of a fun way to condense a lot and try to pass that on.
A lot of learning through the process of this, and then talking about stuff that you haven't been exposed to yet, but you have to learn about. Let's talk about safety in the Astm standards.
Yeah, so what was your most difficult part of this, applying the standards with the adaptation document? I know reading through that's a lot of work. Just kind of how do you guys approach that?
So one of our biggest challenges with that was being able to make sure that all of our other sub-teams were able to understand the standard. So our team was organized into 3 sub-teams, and I took the lead on the standard sub-team. And our group read the standard, but then had to make sure that the applicable parts of it were shared with other team members across other sub-teams. And so that was one of our biggest challenges, is distilling what information did we actually need to care about at what point in the process. So early in the process, we were very focused on material strength and stiffness and making sure that we'd hit factors of safety. While later in the process, we were looking more towards our fasteners and our coatings on materials up to speed, and do those fit in with the standards. And so really trying to figure out what we needed to care about and what we didn't necessarily need to focus on was one of the biggest challenges, at least from the standards perspective.
Yeah, and it sounds like when you guys were designing your ride, you had to incorporate the standards along the way. Is that correct?
That's something that we tried to do, at least. Advantis, which is the risk analysis system that we're supposed to be using, is set up to be more of an iterative process. So you do a first risk analysis and propose solutions to lower risk, and then come back and reevaluate that. Because of our accelerated ride timeline, we didn't really have a chance to do that second iteration. And so lots of our solutions are proposed, but haven't necessarily been implemented. And so that's something that we found difficult to try and work in at the last minute.
Yeah, fighting up against time constraints and making sure that the ride is safe no matter what.
Yeah.
Very much so.
Yeah.
If you guys had one thing to change or have feedback for us, what would that be?
I think one of the kind of challenges that we faced that we would kind of want to look at again is when we started the competition, we started just up on the deadline of when you could sign up. We as a team kind of thought that the program would start on that day and run. We only found out later that you could start earlier and have that more time. So I think as a team we started like at the beginning of January. So we had to rush a lot of the things that we did.
Yeah.
Of course we put the quality forward that we're proud of, and but spreading that out over a few more months may have been nice on our part.
Absolutely. Reiterating on that and going back next year, and you guys have more time, or if you were to do this earlier, how would you guys have changed the structure of your team or your design process, incorporating like more iterations into it?
Incorporating kind of iteration would have been what we had to do because of these time constraints. was to make sure that we hit the standards that were provided. So we made sure everything was over-engineered, to make sure that we hit the safety requirements that we set for ourselves and that are required in any sort of project in industry. But looking back on that, if we have the ability to iterate from the beginning, we may be able to save weight, save cost, while still hitting the same factors of safety that we hit, maybe in a more efficient manner.
Yes.
If you were to do this again, is there anything that you guys would change, what you would do better? Kind of like what thing did you come up with your model and be like, if I had to do this again, we wouldn't do it this way?
I think if we had to kind of reorganize how our ride system is very heavily based on being able to control on moving parts. It's very broken down. Creating one structure that can kind of unify a ride experience for everyone, I think would have saved us a lot of time in the process, as opposed to trying to manufacture and analyze for a number of ride profiles across the whole system.
How did you guys go about forming a team, recruiting people, or did you guys already have a club organized?
Yeah, so we are part of CAPE, the Cal Poly Amusement Park Engineers and Designers. And one of the things about Cal Poly is that we are a polytechnic school. So we are an engineering kind of focused school. And because of that, we're kind of an engineering focused club. So when we put out a call to our members that we had a ride engineering competition, a place for them to learn engineering skills and practice the learn by doing philosophy that Cal Poly is kind of known for, people jumped on it. We were able to get signups incredibly quickly, and people were very excited to begin.
Lovely. Well, thank you guys for coming out. Do you have any like fun memories or stories from coming out of this? Crazy items or anything? Inside jokes that we might not be able to catch up on.
If you ask any of our members what a meat apple is, they will have very painful, very fun memories. You can see the faces of some of the other people in the Zoom that are excited about it. You spend this much time with people, you get fun jokes that don't translate.
You become a team.
You become a team. You become a family.
That's lovely.
Awesome. Well, thank you again.
Yeah, thank you guys for coming out to this competition, and I hope you show up next year, and I wish the best of luck to you guys for the rest of the day.
Thank you very much.
Thank you.
Thank you.
Thank you.
for our final final team in our contactless league. We have UC San Diego. Howdy, can you guys hear us?
Yeah, we can.
Awesome.
At least I can.
Got one. Perfect. Then let's get on with the interview. Tell us about your ride.
Yeah, so our ride is a flying carousel kind of ride. It combines a standard typical carousel like you would imagine, like horses going around in a circle.
Mm-hmm. Awesome.
I have YouTube going. I thought you were asking me a question. That's what was going on. Sorry.
No worries.
And it's also a drop tower experience as well as an aerial carousel like the Dumbo ride found at Disneyland. And there are many other rides like that. And so we combined that all into one experience.
Why did you guys decide to go down this route with your design and ride?
Brendan, do you want to answer that?
Yeah, sure. Yeah, it was very much a multi-stage process. At first, we wanted to collect all of our team members' ideas, and we compiled them into a Google form, and we wanted to look at all of our concept design. And it seemed like we all collectively either had a drop tower, a carousel, or something like that. So we said, well, we all like these ideas, so let's just combine them. So that's where that idea came from.
That's awesome.
Lovely. When designing this model, what did you learn about the process and going through it? You said you were incorporating everything that you could in, right?
Yeah, definitely there were some things that we eventually had to get rid of. There were certain, especially, aesthetic choices that we had to either change or get rid of just due to, CAD constraints, time constraints, and things like that. But in the end, we were happy with the things we were able to incorporate, even if it wasn't everything that we had from Blue Sky, because Blue Sky, you come up with tons of different ideas.
All the ideas.
Yeah.
Well, what was the hardest part about incorporating the ASTM adaptation document with the F24 standards? And is there any suggestions you guys would make as to changes to that for the future competitions?
Yeah, definitely. I think the hardest part for us was, since we're in the contactless league, we weren't exactly sure which standards applied to us because we didn't have a physical model. For example, we couldn't do any of the empirical testing because we didn't have anything to actually, use sensors on or whatnot. So I think figuring out what was within our scope and staying consistent with our assumptions, for example, the riders being inanimate objects. So trying to stay within our scope, figuring out what our scope is, and applying it to a ride that doesn't actually exist. I think that was the hardest part. So I guess if I have a suggestion going forward, it would be for you guys within the committee to tell us a little bit more specifically what we can use for standards for contactless league in particular.
Nice.
I think that'd be helpful.
How has COVID affected your club with social distancing and getting together and stuff like that?
Yeah, that's a really great question, because originally we were trying to do a model. Back in November when we started the project, we really hoped that California would open up enough and that people would be moving back down to San Diego, but that never happened. And so we eventually had to change to a contactless league because we were spread across multiple states. No one could meet together, and it was just, it was too hard to do. It was too difficult, but that's the same story for a lot of different people, we understand. And we're just really happy that there was a contactless option, so we didn't have to give up completely. We were still able to do a lot of great engineering work and learn a lot as part of the process.
Awesome. So tell us a little bit about your club. What kind of things do you guys want to do in the industry? What's your dream position?
Sydney, why don't you take that one?
Yeah, so I guess since we're all like engineers, I can't really say for everyone, but for myself, I'm trying to like go into like ride engineering. So this competition was like pretty much a perfect opportunity for those who have like the same goal as myself, and for like Jared and Brenda. I'm sure you probably have like different ideas, but like the ride engineering competition really provided us like insights into how ride engineering works that you can't really learn in college. That's something you pretty much learn at the college. So having like this competition really like sets the tone for like what we can expect as we come out of college and get into the theme entertainment industry.
Talking about being a part of a team, and you guys, and what's the composition of your team? Are you guys mostly mechanical engineers? Are you just engineers? What are you guys made of?
Yeah, I think currently all of our members are engineers. We did have a little bit of help, so I guess she's technically a member from someone who is doing more like the art side and stuff like that. So I guess she's not an engineer, but she does a lot of technical art, so like digital drawing. But the rest of us doing all the design work, we were all engineers. Our club, TA UCSD, is very varied with our different majors. But the people working on this project were just a subset of those, and it tended to be more engineering focused just because of the nature of the project.
Oh, absolutely. Awesome. Any fun stories from this whole project and you guys working together online? Or inside jokes?
I mean, yeah.
Sorry, go ahead, Brenda.
Yeah, that's a good question. It is, the dynamics are very different when you have virtual meetings. Things can still get kind of silly, though. I mean, my favorite thing, I don't know, I don't want to throw Sydney under the bus, but we had, one of his initial concept designs was just a beautiful Pegasus. And that's been like a staple of our team. I try to put that concept art whenever I can into what we work on. So that's one fun thing.
When she says beautiful, it's being a little bit sarcastic. No offense.
Oh yeah, definitely.
Oh.
Don't remind me.
I got the point across. That was the main point, right?
There you
knew
go.
Exactly what you were trying to draw. So.
Looks like a horse, so it is one.
Exactly.
I know the California theme parks are just opening back up. Have you guys been to any yet?
Not yet.
Okay.
Nope, I have not. Yeah, I think Disneyland is slated to open April 30th or something. Yeah, I live in Anaheim, a couple miles from Disneyland, actually. So that'll be interesting to see how that goes.
Yeah,
definitely.
Looking forward to next year. If you guys decide to participate, how would you change either design process, team dynamics, and all that?
I think one thing I noticed is I almost feel like we spent too much time in blue sky. We spent a lot of time getting different ideas and trying to make sure that everyone was happy on the team. But the thing is that certain ideas have to get thrown out, and you know, certain people have to make decisions on what's good and bad. And I think that once we moved into more of the design portion, you know, doing the CAD and things like that, we were all able to be a lot more involved instead of it just being kind of like one mass team working on one decision at a time. We're able to get a lot of individual things working simultaneously. And that's when I really saw our team members shine. And I just wish we had started that earlier, because I think we could have done even more iterations and more individual work, which I really appreciated from everyone.
Awesome. Nice. You have anything else to add, Nate?
Further questions? Let me check the document. Let's see.
I guess we also hope to actually build a ride model in the future.
There you go. Yeah. Absolutely. When you guys, when it comes, we talk about analysis of the rides and going through several iterations through a computer design. How did you guys do that necessarily? What was your thought process, or were you able to get some of that through time and such?
Yeah, we were. Basically, every different way we could, we did.
Yeah.
So, for example, for the control system, we didn't really have to actually do Arduino code for everything, but we tried to pick certain parts of the Arduino code that would be most important.
Yeah.
And then I just had a little LED hooked up. So, I mean, it just showed that, it got brighter or darker, but I knew exactly what that translated to, if it was connected to a motor and a whole ride system.
Yeah.
So we were able to test certain parts. We used finite element analysis to test our CAD design, and we did a lot of different calculations and tests that we could. You know, we tried to do as much real life stuff we could without actually building the ride model, because we knew that that wouldn't happen.
Yeah.
That's really cool. That's really cool.
That's all the questions we have for this interview. Thank you guys for coming out.
Yeah, thank you guys very much.
That'll be,
thank you.
Yeah, thank you.
Thank you.
That'll be the last team for Contactless League. We're going to take a short break for around 15 minutes, and then we'll be back soon at 10:30 with the University of Cincinnati. See you guys soon. Next up for interviews, we have the University of Cincinnati. Howdy, can you guys hear us?
Yep,
Yes.
we're good.
Hi.
Cool.
Awesome. Let's get into it. Tell us about your ride.
All right, so our ride is called Accelerator, and we were inspired by the S&S Scream and Swing, specifically Skyhawk at Cedar Point, and then also Huss Top Spins, like the former crypt at Kings Island. And we decided to try to combine those two concepts. So on our ride, in addition to the full swinging arms, the seats themselves are able to freely rotate. And the original idea of our ride was to have a motor and a gearbox to rotate the streets or the seats manually, but unfortunately that wasn't able to materialize. So now we've adapted it to work like with ball bearings, and they rotate freely like an S&S free spin. Or an intimate spin. Yep.
Awesome. Why did you guys decide to go down this route with your model?
Well, with the requirements for this competition, having a ride to go or to transport riders at least 300 millimeters above its starting position, we knew we wanted to have a vertical ride. And with the rider capacity, having 32 riders per minute, you need one that can house a lot of guests in a short amount of time. And the S&S Scream and Swing, you can have 2 arms, and we've got 16 riders on each arm for 32 to meet that requirement. So, yeah, that's the basic reason we chose this type of ride.
Yeah.
Awesome. How did you guys incorporate safety and the ASTM standards that we gave you guys into your ride?
So we did risk assessments, obviously, and we put safety precautions like an e-stop is one of them. So it'll reset the riders back smoothly if we recognize anything is going or is malfunctioning with our ride, and that way no one would get injured.
Yep. And we made sure the proper spacing was there for everything, including for the riders' arms on the ride, even though they don't really exist with the stuff. And yeah, we designed our restraints to be foolproof, like the riders can't get out in any way, just to the shape of the riders.
And we designed them to, there's a applicable enough space between them and the floor so they don't,
bonk.
Hit the floor.
Yeah, exactly. So, yeah, just a lot of planning. Yeah.
That's really cool. If you guys had to change one thing or had feedback for us on what we could improve with the competition, what would that be?
For the competition itself, maybe just more resources on where to find stuff. We had a lot of trouble finding a motor that would work for this competition. None of us had a lot of background on that, so I think resources, maybe have someone who's built a ride model before give a presentation. I think that would have been extremely beneficial. That's probably the biggest thing I can think of. So,
thank you very much for the feedback.
Could you guys tell us about the composition of your team, whether that's degrees or backgrounds and all that?
Yep. So our team consists of 2 mechanical engineers and 3 civil engineers. And both mechanicals and 1 civil, Brett, are in their 4th year of 5 at Cincinnati due to our program. And then Will is our senior, he's a civil, and then Matt Novak is a 2nd year civil. And so it was definitely a challenge for mechanicals and civils to come up with the Arduino and the coding and everything. Brett really stepped up and did that. So this project really allowed us to work cross-disciplinary, with stuff we don't normally touch in our classes. And that helped us learn a lot more about like the full ride system rather than just parts of it that we can take things from our specific classes.
What are the people in your club looking for in the industry? What kind of jobs do you guys looking for eventually?
Mainly, I guess, really, a lot of rider attraction design and especially roller coaster design. Because there's a lot of roller coaster enthusiasts in our club.
Yeah, and we have some business majors too.
Yeah,
actually, we have some people in our club that are looking at the marketing side of the industry and like the operations side too. So we've had speakers come, that have nothing to do with engineering to our club. We're a TEA club, not a TPEG club. So we're a little broader than that as a general club. And I think that's more fun because, again, you get to see more of the industry there too. And yeah, I think I would personally also like to go into ride design. Right now I'm working at Kings Island, and I'm learning a lot more about the rides in the off season, doing maintenance on them, and
awesome.
It's got me a lot more interested. So yeah,
that's awesome. Thank you guys so much.
Looking forward to next year. What would you guys want to change about this, whether that's your project group or design philosophy?
You can go ahead.
Probably more the, I guess, design philosophy, because first time this competition's ever been done, we not know what to expect at all, or how hard, and especially in this COVID year, trying to find ways to gain resources or meet. That's definitely a big aspect, especially along the lines of if 3D printing parts, of learning process to getting those to fit smoothly and cooperate with your ride.
And then another thing we'd want is probably ideally a couple more disciplines and like a more diverse group with different fields of study, because we had the civil and mechanical systems down pretty well, but like a lot of other stuff we were just doing our best to research and figure out how to do it. So yeah.
Tell me a bit about the theme of your design. I'm just kind of curious.
Yeah.
It's a lumberjack theme, and we had it because since our arms are going to be swinging, lumberjack swing down onto, chopping wood, so it would just look like two giant axes moving back and forth.
Yeah.
A very visual ride.
And I don't know if you guys have seen our video yet, but part of the marketability with this ride is it can be rethemed so easily, because we came up with a lot of ideas for other things that swing. And in that video, we have a couple of our other concept ideas that lost out to the axes ultimately, but we also thought were really cool. So.
Absolutely.
Awesome.
And we'll be airing your video right after this interview. How has COVID affected how your team is organized?
It's made it definitely more online. Obviously, we've worked in OneDrive a lot and just made sure we all let each other know when the most updated version of stuff is in. We modeled our entire ride in SolidWorks and did all the lines in there. And so we were able to collaborate pretty well on that. And then just meeting up to do calls to write the risk assessment together and everything. Then meeting was a big challenge. At UC, we're very fortunate. We just got a new center put in on campus that's essentially an innovation hub. But due to COVID, they have very limited hours and very limited capacity. And so we got in there when we could and got 3D printing done when we could, but that definitely made it more challenging. And hopefully next year, their hours will be as flexible as they were before. So
awesome.
Yeah, that's really cool. Any fun stories or inside jokes from your guys' development?
Yeah.
Well, it just happened earlier when we were testing out the different speeds of the ride. We had the program running too fast and our arms were going crazy. And they were causing the arms to whack on the floor, and it was like, okay, that fast.
Yeah,
not that fast.
It went really extreme. We had to unplug it. Yeah. So that code definitely needed to be changed, and then just the speed real quick, and then also the biggest challenge for us has been we're having an issue right now with our couplers on the top to connect the motor to the axle. We've tried so far 5 different ways in the last couple of days to get it to connect, and I don't know, we keep thinking of something new, and I think what we've got is our best shot yet. So
awesome.
We look forward to testing it shortly. So
absolutely. Well,
yeah.
Anything else?
I don't believe so. Thank you very much, guys.
Yeah, thanks for showing up. Thanks for competing. I hope the best for you guys.
Yeah.
Now we're about to.
It looks very nice.
Yeah, and now we're going to watch your promotional video in a bit. Thank you.
Awesome.
Thank you.
Thank you.
next up for interview is Ohio State University. Ohio State, can you hear us?
I'm clear.
Awesome. Howdy, how are you guys doing?
Doing all right. How are you guys?
Doing good, getting by.
It's a Saturday.
Yeah.
All right, let's get into the interview. Tell us about your ride.
All right, so our ride is based off of a Zamperla Nebulaz, but it has rocking seats that have the ability to invert, and it's themed to cows getting sucked up by a tornado.
Yeah, we went through a lot of ideas in the seating process. Like we basically, because if you know the original Nebulaz ride, the cars are a little like plain looking. We wanted something more creative that would stand out more. Went through various iterations, and then we were eventually inspired by a tornado and that famous scene in Wizard of Oz where you see all those things flying around. We're like, oh, there's cows. That's kind of funny. I think that's cool. We should run with that. And then we made the cow cars that you see.
Yeah, I think we're most proud of our theming because it's something that you remember, even if just to think that it's funny, and then you want to try it out, and it actually ends up being more thrilling than you would think.
Awesome.
That's really cool. What did you guys learn from designing your model? It looks very detail-oriented, like you said.
Yeah, on the other side of that, though, we had a couple of issues that we learned. So for one, it's not a good idea to have a round hole with a round rod to try to get it to rotate. You're going to have to use a key stock or like a cross section or something because we're having a few issues with that.
We had a lot of issues last minute when assembling the thing. Things weren't turning properly. Things were coming loose. The glue wasn't tight enough. Pretty much it could have been a lot better planned.
But we also had a few places to learn with the motor and the capability of the motor that we had last minute. We realized it wasn't generating as much power as it should have. But we were able to kind of come up on the fly with a bunch of new stuff. And so it operates whenever we push it manually. So we're super proud of what we have so far.
That is awesome.
Could you tell us about safety and incorporating the ASTM standards that we gave you guys?
Well, obviously, the first thing to do with that, with safety, is restraints. Because it can invert, it needs, I believe, a class 5 restraint with or class 4 at least, with 2 points of contact. So what we do is we have the rubber band that emulates a lap bar and shoulder harness, so it goes across the front of the riders and on top. So there you go. It can be both, really.
Yeah, those are very secure in those seats. Another thing we had to keep in mind was making sure the arms were staying attached properly. We were not having any collisions. The spinning mechanisms of the Nebulaz are very complex, and they have to be aligned almost perfectly before you start moving it, or else they're going to knock into each other. So that was something we also really taken into consideration. Also, clearance with the ground and the staircases for loading was important as well.
The gear train, so if one gear moves, then they all move, and so there's less room for error there because they're all going to be moving together as a system.
That's awesome as well.
Tell us a bit about TPEG OSU. I know you guys just had Sight Light a little while ago. How did that go?
All right, so I was actually on the planning committee of that. So we basically just had to make a virtual event of Sight just to keep the name out there and also to connect students again after this year of not really many connections happening because IAPA got canceled. There was no real ASTM. It was all virtual. So we just wanted to have a network focused on students so that we can keep connections kindled for years to come.
That's really cool.
Overall, it was a great success. It was a really fun time, and meeting new people is always fun.
What are the people in your team and a part of your club looking for further on after college?
So we'll just start with us three. So personally, I'm a mechanical engineering major, and I'm looking obviously to get into the industry, specifically on the ride side of the industry.
Yeah.
So hopefully we can pursue that in the future.
I'm also a mechanical engineering major. I'm a sophomore this year, and I too am interested in themed entertainment, but I think more on the theme side of it, where I really like a lot of design stuff, but I'm also very fascinated with how it works in mechanics.
I am the only electrical engineering major, and I too am also much more into theming, but from joining this club, I've had a lot more exposure to like the thrill side and like the roller coaster, and I'm very eager to learn more because there's so much I don't know. Like being next to Ryan is like very intimidating because he knows like literally everything. He is a genius, and I have so much to learn from like him and other people in the group, and I'm very eager to learn more of stuff I don't know because there is a lot I don't know, and I want to get into the industry in some way, whether theme or like thrill side. I'm kind of fine with either, but I am pretty like interested in like electronics and like that kind of side of the industry as well.
Awesome.
Do you have any inside jokes or anything fun that happened while designing? Or Just anything?
So all of the cows have names,
Yes, we all
and
know
they all
those
have
cows.
distinct marks. So we each got to name 2 cows. So there's just some kind of funny jokes between some funny references, and we have Muhammad is one, Maurice. We have a Bessie, a Cowrie Bradshaw,
Milky Bets.
Milky Bets.
One of mine, because my name's Connor. I named one Phil after Phil Connors from the movie Groundhog Day. I named one Sarah Connor after Sarah Connor from Terminator.
Oh my gosh, that's awesome.
Could you guys tell us about the composition of your team and your club in general? Are you guys mostly engineers?
So our club we started off mostly as engineers, but this year we've branched out where a lot more business majors have joined.
Yeah.
So we're also extending our arm to like business majors and having some content for them to do as well. So we actually just had a project that was focused on business majors. I can't speak for it because I didn't really take part in it, but from what I heard, it was a big success.
Awesome.
That's awesome. How many members do you guys have this year in TPEG OSU?
First semester, we had a lot more. We were regularly getting like 35 to 40 people.
Whoa, jeez, that's a lot.
Yeah.
Holy crap.
This semester, it's been this year, like, being online, people have like less motivation to go to weekly meetings, that sort of thing. But the people who have gone, like I go to pretty much every weekly meeting. It's a really good time. We all have some great discussions about the industry and just talk about life in general and have fun with each other. We usually have a group of about 15 now.
Yeah. One of the reasons I like it so much is because you can always stop by any meeting and you never really feel like you missed anything. So you can kind of step in on any bit. So it's awesome because people can continue to be added even if they felt like they missed it at the beginning of the year.
Because every week is sort of its own unique thing. Like sometimes we have guest speakers. Sometimes we just kind of generally socialize and talk about stuff. Sometimes we have fun games planned. It's always a fun time though.
That's really cool.
Could you guys tell us about how COVID has affected you guys when you're planning and doing and
Okay, well,
executing
one of the biggest setbacks we had was like cooperation with OSU and getting access into like these buildings and access to lab space to actually do work. Like we went into our lab like one time last semester, and then after that they were like, no more clubs in-person meetings. We were all virtual, and then we didn't get the key to our lab until very recently, and then we were trying to get cooperation with the labs here to get things laser cut and into their like lab space to access the tools. That was definitely the biggest challenge because they have stronger restrictions now because of COVID. Yeah, basically, we only had a month to do everything because
not even like a couple weeks.
Yeah, a couple weeks because they only just recently let us do in-person stuff again.
But we're very fortunate for our advisors and the people that contributed to help us because there was a lot of people that came in clutch last minute through the university, and we would be nothing without
I would not be assembled without them.
Awesome.
Well, that's really cool that they let you guys, go back to in-person.
Yeah. I mean, it is just 3 of us, so it's not like that big of a deal.
Yeah. Looking forward to next year, how would you guys change?
So we're trying to go back to fully in person next year, obviously, as I'm sure everyone is. So, but we're going to use lessons that we learned through COVID. For one, reaching out to more business majors to try and make it more accessible to everyone who's interested. Yeah, because in the title theme park engineering group, it's not really clear that we accept all majors in our club, not just engineers.
Yeah. We struggle with the same thing here, so that's an exclusive deal.
Yeah, there we go. So yeah, we're just going to try and broaden our horizons and keep going through whatever we do. Virtually, it can be easier to reach more students than in person.
And it'll be awesome whenever we can have site in person again because I think that's a big thing that we have for networking and everything.
I had a great time when I went there last. It was great.
Hopefully, we can see you there again next year.
Yeah, that'd be great. I'd love to.
Awesome. Do you have any other questions, Alex?
I don't believe so. What about you, Nate?
Thank you guys for coming out. Thanks for participating in the competition, and I wish the best for you guys.
Yeah, thank you guys very much.
Thanks for having us.
Thank you. Next up for interviews, the Rochester Institute of Technology. Can you guys hear us?
We can. Can you hear us?
Yep. Howdy. Yep. How are you guys doing?
Howdy.
Hi.
Hello. All right, let's get into the interview. Can you explain what your ride's about?
Yeah, so we decided to go with a drop tower. We call it the Tigers Pounce because we wanted to theme it off of tigers since we're the RIT Tigers. So basically the idea is, since it's a drop tower, you're going on with the tiger, climbing up the tree and then pouncing down to the prey.
Oh, awesome. That's really cool. Why'd you guys decide to go down this route with your model?
So originally we kind of started we had two designs that we were thinking about. We were thinking about doing a condor style ride, or our rides run in the background, sorry for the noise. Or we were also thinking about kind of like a double top spin. But we had some design reviews with some alumni from our club, some industry professionals, our club advisor, things like that. And they kind of guided us towards the condor idea. And we originally wanted it to be able to get up to the top and have, two axes of motion of spinning and then be able to drop at the end, kind of to make it unique. And eventually we kind of took a little bit to start building, and we realized that we don't really have the time and the capabilities to do that much, area of motion. So we limited ourselves to a single centric drop tower. And our design was supposed to have a central, it was supposed to be able to do the drop tower like it's been doing, and then once it would get to the top, it would spin a little bit.
Awesome.
We didn't quite get there, but we're making it drops, and it has the capabilities to spin eventually.
Awesome.
That's really neat.
Could you guys tell us about your design process going through this and implementing safety into it?
Yeah, so we spent a lot of time, especially at the beginning, focusing on the safety aspects and what we wanted the ride to do. So while we were choosing the ride, we went through a set of different ideas. Everybody came in with a couple ideas. And then we kind of ranked everything based off of different priorities of what each ride had to offer. So we ultimately, as Jesse was mentioning before, we're originally going to go with a condor and went with that because it was a good, a safety option for the riders. And although it did transform to the drop tower, we were able to still keep a lot of those aspects involved with this tower as well. Jesse, I don't know if you want to add to safety.
Yeah, so we wanted to make sure, we wanted it to be a thrilling ride, something that we would enjoy riding. We didn't want kind of a boring, ride that doesn't do much. So that's really why we wanted the drop aspect to it, and we would love to have it spinning. In terms of, one thing that we had to think about, obviously, is, a big part of this challenge is keeping the riders safe. We don't want them flying out of their seats. So we paid a lot of attention to the formation of the seat that they're sitting in so that they can be locked in on all sides while still having free range of motion in the arms. And a lot of our design in terms of the way that the tower works is that there's a counterweight system. So the carriage weight is countered by a counterweight that's all attached to the same motor. So a lot of the motor size and the constraints, things like that, we looked at the Astm standard document, and we were able to use that to kind of help guide our design process, to tell us how big should the pulley be, what size wire should we be using, things like that. So we definitely wanted to make sure that our little riders were safe the whole time.
Awesome. What was the most challenging part of using the Astm adaptation document that we provided? Is there any suggestions about what you'd change with that, or some things that were unclear?
It was just different because, I had never looked through an entire ASTM document at one time. Normally they kind of just, my boss would just point me to the right section.
Yeah.
So there was a lot of information going on all at once. As reading through it, it started to, after a couple read-throughs, it started to make sense. As someone who's fully mechanically inclined, I depended a lot on Pat to kind of help me out with the electrical component things. So that was something that, I definitely had to get used to and had to learn kind of. I knew the mechanical things made sense to me, but I didn't know, why do we need resistors here and things like that. So that's something that Pat helped me out with.
I think another thing with that too is that one challenge we had was applying some of the things that were meant for like larger real scaled rides scaled down to our model. We did have a couple of issues like figuring out what necessarily would apply to something on such a small scale, and how to scale that application down as well. But overall, it was a nice experience to be able to get more familiar with the standards.
Awesome. Could you guys tell us about the composition of your team?
Yeah, so we are mostly mechanical engineers. We have Pat, who's a software engineer, but everybody else, there are seven of us total, so 6 mechanical engineers. Everybody's different years. So we have a couple freshmen and a couple 3rd and 4th years. Everybody kind of was able to had a different strong point. Like, although we are all engineers, like Aubrey was able to make the ride look beautiful. She has a lot of artistic experience. And then like Elijah did a lot of our CAD stuff. And Aubrey did a lot of like our machining stuff, and Jesse was able to lead a lot of our safety stuff. And our freshmen were able to really just learn wherever they wanted to.
Yeah.
So it was a good experience all around.
Awesome. Tell us about your club at RIT.
Yeah, so we are the RAT Theme Park Enthusiasts. We've been around for, I think, 5 or 6 years at this point. And yeah, we basically just love doing stuff like this. We usually do, we have a big event called Imagine RAT every year in the spring. This year it's all remote, so it was nice to be able to still build a ride with the club this year, even though it wasn't in our traditional way we were able to do it. But yeah, we have weekly meetings, we do park trips, we do different competitions. So it's really cool to be able to experience this new competition as well.
That's really neat. That's really cool.
Awesome. Could you guys tell us about how COVID has affected how you guys organized your team?
Yeah. So a lot of our earlier meetings were remote. I mean, also because we were on winter break for the first about 2 months of us meeting. But luckily, we've all been able to be on campus this semester at RAT. They've been taking some great safety precautions. So we've been able to meet weekly still in person as a team to be able to build the ride and brainstorm together in person. So yeah, we've taken a lot of like safety precautions and stuff, but we've been able to still be able to get hands-on with the ride. It's been great. Sorry.
No worries. One really thing that's really great about COVID too is that like RIT does co-op blocks. So in the fall I was on co-op, and normally I wouldn't have been able to participate in the team meetings, but now that they're all on Zoom, I was able to. The fall was mostly brainstorming, so I was able to jump in on that and help out.
Yeah, that's really cool. Do you guys have any fun stories or inside jokes you'd like to share?
Okay.
We have a small obsession with Charlie.
Obsession with Charlie, did you say?
He is on set. He will grace us with his presence in a little while.
Very blessed. But I don't know. Overall, we had a pretty good time. I think, honestly, probably the funniest thing is when we've been on Zoom calls and running the ride in the background and then just hearing it and having to explain to people what's going on. So as you've experienced multiple times. But yeah.
That's really cool. What are the people in your club looking for in the industry? What do you guys want to go into?
I think a lot of us would be happy with any kind of foot in the door in the industry.
Yeah, honestly, right now with COVID, anything.
Really. I'm someone who really enjoys like the structural side of things. So to be able to build, structures, make sure it can support the ride weight and things like that is something that I really enjoy.
For me, I'm really into like controls and also like the show aspect. So show control, I guess, would be kind of where I want to go, or animatronics, stuff like that. I really like the story. I'm really into theater as well. So being able to combine both of those aspects would be really cool.
That's awesome.
I can't say I'm really interested in the industry. I just know how to code. I'm in the club, and that's 100%. About it.
Yeah, that's all right too.
All right. Any other questions?
I'm not Sure I do. Do you have any other?
Thank you guys for competing in the competition. Hope you guys do well for the rest of your day.
Yeah, thank you very much for joining.
Yeah.
Thank you. Thank you guys for hosting.
Yeah, thank you guys for hosting and for everything.
And we're going to go watch your promotional video in a bit.
Oh, sounds good.
Thank you.
Thank you.
Hi, I'm Ellie.
I'm Patrick.
I'm Jesse.
I'm Elijah.
I'm Aubrey.
I'm Matt.
And I'm Jessa. And we're the RIT theme park enthusiasts.
And this is Tiger's Pals.
The Tiger Pounce. It's a drop tower kind of ride where our carriage can lift to the top, and then at the end of the ride, it will drop down. The main mechanism here is a motor which carries a pulley drum, and we have a counterweight so that it can balance out the weight of the carriage, similar to how an elevator would work.
So this is our carriage. We have our 3D printed passengers that fit snugly in between these 3D printed dividers and the CNC piece of insulation foam. There's also a restraint disc that goes on top of them, and this disc can easily be removed when we load and unload the passengers. On top and bottom of this layer is 2 layers of wood, and in between these layers is a bearing track so that the carriage can spin.
Hello?
Howdy. Next up for interviews is Virginia Tech. Virginia Tech, can you hear us?
Yeah, we can hear you. How you doing?
Howdy. I'm doing good. How are you guys?
Pretty good. Having a good day of operations.
Nice.
So I'm Spencer. This is Jordan. And yeah, we understand the video is going to be shared first. Is that right?
After the interview.
Oh, gotcha. Okay.
Mm-hmm. So tell us a bit about your ride. I see the beautiful LEDs on it. Looks very nice.
So our ride is a drop tower ride. It's based on the Intamin sky jump model, where it's basically like a regular drop tower, but once you get close to the top, the seats rotate 90 degrees. So the rider faces directly down at the ground and stays in that position even through the drop. So what we decided to do is we themed this particular drop tower off of being abducted by aliens. So the title is Investigation Drop Circle, and it's sort of has a retro 50s vibe to it, where investigators, like private investigators, are suspicious about a closed off area where there's a crop circle that appeared in a local cornfield.
Yeah.
Curious what's going on, they decide to enter the queue, or the little entrance in the crop circle. They follow it around looking for answers, and eventually they reach the center, which is the loading platform. So then they reach the center, they get into the ride vehicle. At this point, they still have no idea what's going on. They're still exploring, but this is when the aliens come in. All the lights turn on, and that's when they're about to be abducted. So then they slowly rise up to the top, almost entering the ship, almost entering. The seats start to tilt a little bit. We intended for lights to flash a little bit during this time, but this signifies that the tractor beam is too weak and cannot properly abduct the riders. So it looks like they're going to make it out just in time, and they do. Right before they reach the ship, all the lights go out, and the ride drops straight down to the ground.
Amazing.
They make it out safe and sound.
Awesome.
So this was a really exciting project we did. The tower stands at 880 millimeters, which doesn't sound too tall, but given the scale, that comes out to around 150 feet. This ride is expected to pull 2.5 Gs, hitting the brakes. So the kind of braking system we implemented was a mix of a few things. So the primary one was magnetic eddy current brakes. So even though they're magnetic, they actually don't use any sort of electromagnetism. So the way it works is it uses something called eddy currents, where there's magnets situated on the ride vehicle. There's a little gap, and on the tower, there's a thin piece of conducting metal. It could be a lot of different things, aluminum, brass. In our case, it's copper, which is actually the strongest available conductor that we could find. The only thing stronger is silver, but I think it's kind of obvious why we didn't invest in that.
Bit pricey.
Yeah. But yeah, we put that on our ride vehicle. And what's great about magnetic brakes is they're increasingly used in not just thrill rides, but roller coasters, because they have a lot of benefits. There's no physical contact with the brakes, but they never wear out. They never have to be adjusted. They never have to be replaced. They're 100% reliable, 100% of the time. The only downside to magnetic brakes is that they don't slow the vehicle down to a complete stop. However, that's never what we intended, because all we wanted was just for the vehicle to come to a speed that's near stop, so then it could gently rest onto the foam mount right on the ground.
Lovely. That's really cool.
Now we actually used different types of brakes as well. We call them track brakes. They serve as sort of an assistant to the magnetic brakes. What they do is they're placed on some of the rails of the track and basically expand the width. So it provides it puts a little more friction on the wheels. And this is a very adjustable, very effective system that you can do to increase the braking force and make sure the ride comes to a complete stop, which is something that we put high priorities into.
That's really cool. Talk a little bit about safety and how you guys have used the ASTM standards and the adaptation document we've provided.
So a big place we utilized that was in our restraints. So our restraints, we're very proud of this design. It's a ratchet system design, and we decided to play it safe, go with class 4, where there's basically a big lap bar that comes down, and it's ratchet. So there's a big gear in the back, some spring steel. So whenever you click it down, it stays there, and the spring steel prevents it from moving back up.
Yeah.
We also made sure that this is a lap bar. So there's bars like on the lower edges, but the riders still have plenty of mobility to move their shoulders, and they're out of reach from pinch points such as the tilt mech hinge or gears that could possibly the ratchet gears that could hurt the guest or incapacitate them. So that was a big thing. But we also provided a couple fail-safe things as well. We had these elastic bands that we put along our riders. It serves sort of like a vest in real life, just to prevent any sort of up and down sort of movement, and to mitigate the risk even more, because you're tilting like facing down, so there's a big risk there. We wanted to make sure the restraints were 100% fail safe. We did sort of an equivalent to a seatbelt in real life. So we used a little piece of Velcro that attaches to the lap bar and the seat. So then you can just use the Velcro, attach it to the bottom of the seat, and there you go.
Awesome.
It's just like a seatbelt. Regarding some other ASTM things, we did mechanical drawings for every single part that we manufactured. Jordan, you actually did some stuff with your cable drum, and Jordan did a lot of work on the lift system, the cables, some of the motors. If you want to talk a little bit about that.
Yeah, so in terms of drawings, we had a lot of pieces that went together in the top lift part, multiple pulleys, multiple pulley mounts, and then the bar spanning the top of the tower was 3D printed in 4 different pieces. So there was a lot of pieces that went into that, and so we made drawings for each of those. And then also part of the lift mechanism was the cable drum, which was 3D printed to custom fit on our gearbox motor, and then the bottom pulley as well, attached to the tower.
Cool. Could you guys tell us about your club over at Virginia Tech?
I'm sorry, what?
Could you guys tell us about your club over there?
Okay, so our club is Virginia Tech Theme Park Engineering and Design Group. And we're relatively new, as far as I know, compared to other T-PED, T-PEG type of clubs. So our presence isn't as big as, say, like RIT, but what we do is we really try to emphasize in getting anyone who has any level of passion for the theme park industry on board. Like you could be someone that wants to like work at Imagineering their entire life and do nothing but that, or it could just be someone that likes to go to King's Dominion once a year or so. It could be anyone interested, and we really want to capture that sort of market. So it's not just like engineering based. We want a lot of different people with a lot of different diverse skills and interests to be all on board, because we're all united in our love of theme parks. And I think a lot of that is actually exemplified by our club president, Ali Rocha. So she is actually an industrial engineering major. However, she also does a minor in theater, and she's very passionate about that. She is also crazy obsessed with Disney. So we got a lot of people on board that are just like that, and we're really proud of that.
Awesome.
Where do you guys want to fit in the industry in the future? What kind of jobs are you guys looking for?
So I sort of followed the classic. I want to build roller coasters, and I think a lot of that came from just my love of Roller Coaster Tycoon. But over the years, I've really grown appreciative of other aspects of the industry. Like, I really enjoy the storytelling aspect of making rides, like transporting guests to like a new environment, a new world where they're just completely in awe about what they're seeing, what they're witnessing.
Yeah.
I think that's all pretty exciting. I do have, I am a mechanical engineer, and I still have primary interest in like designing mechanical aspects of a ride, as this is why I actually led our team here. That's why I was really passionate about this competition. However, I do have a lot of interest in the more artistic side of it as well. I think there's really a lot of imagination that goes into this industry, and coming up with an idea that you're really proud of, really passionate about, like there's just so much satisfaction in that. I did Ryerson 2 years ago, another design competition, and that was some of the most fun I've had in years, and I'm glad I could recapture a little bit of that magic in this competition as well. So
awesome.
So, yeah,
I think we're pushing up against our time limit, and we're about to run your promo video. So thank you guys for coming out.
Thank you guys very much.
Yeah, glad we could be here.
I loved hearing about your thing. It's very nice.
Thank you. See ya.
See you later.
Thank you.
Hello, I'm Spencer McMillan, and this is Investigation Drop Circle. Right near Highway 51, unusual and complex patterns have appeared in a cornfield. Investigators of the Virginia Tech Hokies have decided to take matters into their own hands to find the cause. What could be the source? A tornado? A farmer? Or something else? We'll now join the team of 5 professional investigators as they uncover this mystery.
Gee whiz, this crop circle sure is weird. I wonder what caused it.
Let's investigate by going through that entrance in the crop circle.
And so our investigators walked in a line, or queue, if you will, to find answers. The members of this team all have specialized skills in developing the investigation drop circle. Each plays a vital role and takes their position incredibly seriously. Finally, the team has reached the center.
We made it to the center of the crop circle, but what's that?
I don't know, but it looks like a comfortable place to sit.
Yes, I concur. Let's sit in that comfortable place to sit.
And so our investigators decided to sit down in that comfortable place to sit. Little did they know that this would be the last place anyone would be able to relax.
What's going on?
I don't know, I'm locked in tight. It's like some sort of ratchet system was used. Hey, how about you? Are you locked in tight?
It only got worse.
That's not good. Yeah, I am not digging this.
Now don't you worry. They'll all dig what happens next.
Whoa! What's going on?
It seems the alien tractor beam is weakening, so we are starting to tilt and the UFO can't hold us.
Woo! We escaped! Good thing our fall was slowed by the tractor beam's magnetic and friction-based radiation.
And so our team solved the mystery of Investigation Drop Circle while narrowly and safely escaping alien abduction. How do I know the story? How did I know what would happen? Well, it's easy to know the fate of the future when you're the one behind the control panel.
next up for interviews, we have the writers. Can you guys hear us? Oh, they're having some technical difficulties.
Well, since we're having some technical difficulties, I'll introduce myself real quick. I'm Alex Stein. I'm the acting president of TPEG ISU. I'm very fortunate for Charlie for putting this together. He did a great job, at least so far. I mean, I'm just kidding. But I'm very excited to be here, and these teams are just doing spectacular, and I can't wait to see what the final results are at the end of the day.
Yeah, no, the competition has been going great, and I'm excited about these interviews.
Hello.
Howdy, can you guys hear us?
Hi. Is my ride too loud? I don't know if you can hear it.
No, you're perfect.
Okay, great.
So, if you can hear us and we can get on with the interview, tell us about your ride.
Yeah, so I affectionately call my ride the Jumbo Flying Happy Frogs, which is a funny name, especially considering it has no theming that relates to any of those words.
Yeah.
But the reason I call it that is due to the inspiration behind the ride. So while the ride itself, as I've presented it, as far as I know, is novel, it was based on and kind of an elevation of a next level, if you will, of some rides that I really like. One of them is called Happy Frogs, and it's actually a kiddie ride. It's, how do I best describe it? There's a arm that is holding a frog that you sit in, and that arm is perturbed by a little ramp. And then as you come back down, the arm lands on an air bladder, and so you kind of bounce like a frog. Yeah, and it's, you know, when I first experienced it, I was like, oh my gosh, this is so adorable. This is so cute. It's so much fun. I actually rode it like 3 times in a row. All the little kids were probably like, who is this adult and why is she riding our ride? But it was great. So basically, when we got the prompt for this ride, I was like, what if I make a thrill version of Happy Frogs?
Yeah.
So that's kind of where the inspiration came from for my ride.
That's awesome.
That's really cool. So tell us about designing your model and kind of what are some highlights about it?
Yeah, so one thing I'm really proud of is the prototyping that me and my team is just me and my husband. We're a little bit of an atypical team because we're actually from 2 different schools, University of Michigan and Purdue. We're grad students there. And one thing we did was we did a lot of prototyping with Legos before we actually started building our real ride. I think you can kind of see it in the live stream. It's off to the side. I've got a Lego model that it's actually the second Lego model we made. So we did some prototyping with that before we ever landed on a concept. So that's one thing that I'm really proud of, and I can turn it on if you guys are interested in seeing it. But I was really excited by the kind of organic bouncing we were able to get. Again, really going back to that original inspiration, that was the main driving force. So we tried a bunch of different things in order to get there. So I'm really proud that part at least turned out the way we wanted.
Awesome. Yeah. Talking about safety, how did you incorporate the Astm document into your ride?
Oh man, so that was quite the in-depth review. So since it was just me and my husband going through everything, he did like the entire DFMEA. You know, we reviewed it together, of course, and I did all the F24 standards. So I intimately went through each of the line items and looked at whether we were compliant, whether it applied to our ride. That was an adventure, I will say. But it was good. It caused me to look at some things that I hadn't been looking at before, and brought to attention some different things about, for example, one of the ones that I really zoomed in on was the like harnesses for the riders. I know, we have these little starburst riders, so not quite a normal person, but and I didn't get to fully realize everything that I designed in my model, but in my CAD, I went into a lot of detail on that. I found that part really interesting. So, yeah, I hope that answers your question.
Awesome.
That's really cool. What are you and your husband looking for in the industry eventually?
Yeah, so we're, again, kind of atypical in that we both are in the automotive industry already. We've both been working at General Motors for about 5 years now.
Wow.
So we've got some engineering experience, but in a different industry. And one thing that I do at GM is I kind of walk the line between technical engineering and the creative designers. So as you all know, it takes both form and function to make an awesome vehicle or ride. So I kind of like walk the line to make sure that the creative vision comes through, but it also meets the technical requirements. So that sort of marriage of kind of two different ways of looking at things is really where I like to be, whether it's in the automotive industry or maybe someday in the themed entertainment industry.
That's really cool.
Could you guys tell us about your design process in making this model?
Oh man.
Yeah.
So first, we did a lot of looking to see what was out there and looking to try and understand how the rides that we thought were kind of similar to what we were going for, how they worked. So I watched a lot of YouTube videos. I looked for blogs that would tell me, oh, what's the arm length of one of the rides we were looking at was the Great Barn Swing. Those great big swings that are in different parks. And I was like, okay, how long are those arms? That would be a good thing to benchmark. And things, and how fast do they swing? And so we did a lot of benchmarking. And then we actually started, our design. We did a lot of doodling to try and figure out, okay, how are we going to get this motion that we want? And then, like I said, we started making Lego models. And that was really helpful for us to actually see something, touch something, have it be in about the right scale. Because the scale part I found a little challenging. Because we're both in the automotive world, so we're, thinking about things at their full scale for cars and things like that. So I'm like, oh gosh, I got to scale it all down. And me and my husband both do a lot of robotics. So that actually was very helpful as well, kind of bringing in, we luckily have a lot of robotic components lying around our house, so we were able to prototype pretty easily. We were able to pick up, 2 motors and turn them on and see how fast they spun and how much torque they had and be like, okay, yeah, this one's going to be a lot closer. Let's go double check its specs. Yeah, this is the one. And that was really nice. We had our own catalog of electronics. So, and then we took it into CAD, of course, and started buying the components we needed, 3D printing the things we weren't sure we'd be able to make very quickly without access to a machine shop. So that was our process.
Do you guys have any feedback for us? Anything that was confusing? Any difficulties?
Let's see. So far, it's been pretty good. I had some technical difficulties at the beginning of the session, just getting my other Zoom to work. But that's not your fault. That's just the nature of being remote. So I also am looking forward to hopefully we can all be in person next year.
That would be wonderful. I'd really enjoy that.
That would be cool.
Well, awesome. Thank you for competing and coming to this interview.
Yeah, thank you so much.
Yeah, thanks for having me, and thanks for hosting this awesome competition.
100%. And we're about to show your promotional video that you submitted for us.
Oh man, that'll show everybody the Lego models.
Yeah, absolutely.
Did.
Awesome.
Perfect.
Yeah.
Sweet.
All right.
Thank you. See ya.
Thank you.
Thank you.
Presenting the Jumbo Flying Happy Frogs by Ryder Riders, the husband and wife team of Alex and Paige Ryder. Before we show you our final model, we want to tell you about how we got to our final ride concept by prototyping with Legos. Our first concept utilized the restoring force of spring-loaded arms. Let's watch that again in slow motion. A rubber band was stretched when the black wheel rode under the red ramp, and when the wheel was released, riders were flung into the air. Our second concept replaced the rubber band and added a second arm to counterbalance the first through the use of a 4-bar linkage. The wheel now rides on top of the ramp instead of under it in order to push riders up. While we loved the visuals of this design, we simplified the final concept by using counterweights instead of linked arms. We won't be showing off our final ride model today. You'll have to tune into the ride engineering competition on April 17th to see the premiere of the Jumbo Flying Happy Frogs.
next up for interviews, we have Notre Dame. Notre Dame, can you hear us?
Hello there.
Howdy. Hi. How are you guys doing?
I'm doing pretty well. How about yourself?
Doing good, getting by. Yeah. All right, if you can hear us, let's start the interview. Can you tell us about your ride?
Absolutely. Would the mechanical team like to start and with Jake?
Either or, yeah.
My apologies. We were just getting everything settled here on Zoom. So, our ride is Dr. Tremble's electrical experiment, and basically the giant Ferris wheel that's smashed together with a drop tower. And so what our riders experience is they ride up the Ferris wheel as the machine is revving up, and Dr. Tremble, who is the arch rival of Benjamin Franklin, is trying to one-up Ben Franklin, having just discovered electricity. Our Dr. Tremble is now trying to put live humans as close to electricity as has ever been witnessed before in this contraption. So when they get to the top, what happens is we pull them off of the Ferris wheel and into a drop tower, and then that drop tower gets struck by lightning as our guests plummet back to the earth, just barely escaping Dr. Tremble's electrical contraption.
Awesome. That's really neat. What did you guys learn while designing the model? What kind of challenges did you come up with?
Yeah, we were able to find like a great deal of challenges within the model. This is something that we've never done before. It's really a one-kind competition. That is something that we've never really encountered, not in classes, not in T8MD. So we were able to face a great deal of challenges within stuff like the risk analysis and the compliance, Astm compliance, for things that we've never done before. But then also in building a mechanical model, just getting the precision that was necessary to build the actual attraction with various machining techniques that we used in creating the attraction. It required a lot of work just to ensure, completely ensure that it all came together as a whole, and each thing that we created would be completely compliant with everything that we needed to actually do.
Yeah. Talking about compliance and safety, could you guys talk about how you incorporated the ASTM document that we provided for you?
Yeah, so we really used that to drive our design. If we were to design something and it wasn't compliant, we would have to completely redo it. So we really used the ASTM standard to drive our design and ensure that we were completely compliant in creating an actual safe attraction while we were using the mechanical design and electrical design.
Mm-hmm. Is there any suggestions about something we should change with the adaptation document, or did everything kind of go smooth sailing with that?
It was a lot. It's something that we hadn't really. It's something that we hadn't used before. So there was a lot of stuff. And then just the biggest challenge was again just keeping everything to scale. A lot of that's built for full models and full attractions. But again, this is just a small attraction that we're building ourselves. So again, that was just the biggest difficulty, making sure that everything was converted from like a full-scale attraction to the 1/50th model that we actually created.
Mm-hmm. Could you guys tell us about your club over at Notre Dame?
Yeah, so Jake Buckler, I'm the president of the club here at Notre Dame, and so we only started just back my freshman year, about 3 years ago or so, and we've grown quite incredibly over these past 3 years. We started out, small, as all clubs do, but we're at a point where we actually just received the Best Club Event of the Year award at the award ceremony at the University of Notre Dame for our Lego Kingdom theme park. So each year we partner with the Lego Club and we spend, about 20 hours building one massive Lego theme park, right? And it brings people from the community in, brings the Notre Dame community together. And so we try to host events, that don't just benefit our members, but that drive our members into the community and that bring the community to TEA at ND.
That is really cool. That's really cool. Do you guys have any concerns with COVID? Like, how's it affected the competition for you? How's it affected your club? You ready to get back to normal type thing?
Yeah, we're definitely blessed here at the University of Notre Dame. We're all in person here. We're all calling in from the same building. And so we're thankful to the administration and all the incredible people here at Notre Dame who've made this happen for us. So, the shout out goes to them first, of course. And so, obviously, yeah, we're ready for things to get back to normal. It's a shame as a senior, to kind of have this be the finishing touches. And it's really tough. The fabrication shops on campus and things like that are highly limited due to COVID. So it's been a challenge to get all of our parts manufactured and run through and to really sort of push this project and have large group meetings. Zoom is incredible, but it's tough to really bond with that team and like build that project together. So keeping that in mind and kind of dancing around that is certainly a challenge. But I think we've, over the past year learned to master that dance, all of us in this earth. So it's a pleasure to present our work of that here for ISU.
Yeah.
We're very thankful for you guys, even with COVID doing this.
Yeah. Could you guys tell us about the composition of your team?
Yeah, so we had 12 members partake in our team. I don't know the exact numbers based on like majors and stuff, but we had multiple members from the College of Engineering here at Eddy, consisting of mechanical engineers, electrical engineers, computer science, and all sorts of things. Along with, we had industrial designers join the team and a business majors as well.
Awesome.
So we really had a diverse team that we're able to use, and that was really helpful as we were able to kind of recognize that each of us had a unique skill set that we were able to bring to each meeting. So we were able to use business student skills in the bid estimation and stuff like that, along with creative skills from students in the College of Arts, and then of course the mechanical skills of students in the College of Engineering. So yeah, we had a really diverse team composed of people of all different ages. So we had seniors, juniors, but we also had freshmen involved, which was great to be able to get them involved and like get them hands-on experience in a unique field. 7, 8 months into their college life, and stuff that you wouldn't even see in a class event.
Awesome. Where do you guys want to fit into the industry? What are your guys' passions?
Yeah, I mean, that's such a crazy question. It's tough for me. Yeah, I mean, you can go with the classic answer. I just want to be seeing people smile. And that's kind of the core of it. Is how can I bring that joy that so many have brought to me through themed entertainment? How can I pass that on to the next generation of folks? Right. So that's kind of the core of it. For me, I'm actually highly involved in the robotic football club here at Notre Dame. So robotics are a passion of mine. So also animatronics are quite fascinating to me, and kind of finding ways to bring those even further to life. Definitely where I'd love to be.
That's awesome.
Yeah, for myself, I'm a mechanical engineer. I love making things work. I love being able to kind of create stuff, kind of like we've done here in this competition. So I just know in the industry, I want to be able to kind of build and create, work through various engineering tasks to create something physical, and again, make people smile. One of my favorite things about TPE is learning people want to incorporate their various majors into something in the field. Ever since I was a kid, I've known I wanted to be an engineer, so I always kind of thought that, this is like what you do as a right engineer and whatnot. But learning about how kids in computer science or electrical engineering want to become involved in game entertainment is just great, and it's really interesting to see.
Well, that's awesome to hear. That's awesome. For those of you who are coming back next year, what would you guys want to change about your process?
Yeah, there's a lot that we've learned. Definitely, again, using the risk analysis and the compliance again to drive our design process even more. Along with just kind of making sure that we work ahead and don't have the long nights that we've had the past few weeks, and just keep everything manageable. And one of the challenges that we had was that just the primary phases of the competition, we were all from home and we weren't back at school for the second semester. So kind of working, I think that's something that'll really improve in the next year as we're able to work throughout all of the winter, the month of January, and all of December as well, to create our attraction. And then just again, working ahead and working forwards, so that we don't have kind of the late nights that we've had, and just making sure that we're on top of everything. It's definitely been a really good learning experience for all of us. And we've encountered quite a few challenges, but we've really learned how to overcome those and create a successful attraction.
Yeah, there may have been a set of parts coming in at 8 p.m. last night that we had to kind of start to slap together. So
hey, it's moving though.
To get those a little earlier than 8 p.m. the night before next year.
Thank you guys for coming out.
Thank you for coming on.
That's a pleasure. Thank you for having us.
Yeah,
thank you.
Hope you guys do well for the rest of the competition. We're about to start playing your promotional video that you guys submitted us.
Thank you very much.
Perfect.
Thank you.
Thank you.
Have a great rest of your day.
So I was able to lead the thematic design team for the ISU competition. One of the members of our group came to us with the idea of combining a Ferris wheel and a drop tower. We settled on this steampunk theme with an amazing story that we came up with. The center character around our story is Dr. Tremble. He's a evil, mad steampunk scientist from the 1750s, back before even the founding of America. The scientific arch nemesis Benjamin Franklin has just discovered electricity with his kite and key experiment. So in order to one-up his scientific nemesis, he now wants to do what no other scientist has done before and send live humans, the riders or his lab assistants, up to the sky to view lightning at its source. So we took that story and we turned that into kind of a ride sequence. So the riders will spin around our wheel as Dr. Tremble is cranking up and charging his contraption. They'll then pull out into the drop tower, which they will then be struck by lightning, which is going to be the climax of the ride. They will then fall down back into the station. So we were really in charge of the thematic direction of what the ride was going to look like. So we chose a bunch of different steampunk colors. The goal was to make this contraption look as kind of put together with many different moving parts as possible.
So our Ferris wheel is driven by a planetary gear train. So we have a 12-volt motor from Banebots operating a sprocket chain system that drives to the center sun gear. The sun gear on the backside of the Ferris wheel then operates the 4 planetary gears around it, which in turn drive the ring gear to give our guests the motion of the Ferris wheel. Our elevator serves as the drop tower section of our ride. And so that dropping motion is achieved with an elevator cup that we use to pull the gondola into. When the gondola has been engaged within that cup, we then have 2 cables that are attached to the top and bottom that are then running over pulleys on the top and bottom of the tower itself. Over those pulleys and onto the outside, we have those ropes attached to a winch drum, which is going to reel the rope in the sort of the same direction. So they're wound in opposite directions around the drum. So when we spin the drum, it'll pull one rope down and the other rope down, so they'll move in the same direction, leading to the lifting and dropping of the ride vehicle.
The controls team has been working closely with the mechanical team to ensure all systems are functioning and functioning safely on our ride. The control team consists of 2 sub-teams, the electrical and the programming teams. The electrical team has been working on circuit analysis, as well as working with programming and mechanical teams to determine the best materials for the job. For instance, after deliberation, the team decided to use an Arduino microcontroller rather than a Raspberry Pi, as its capabilities were more closely in line with what we needed to make the system run. For instance, a Raspberry Pi might have been able to connect with the internet. However, as we do not need this functionality for our ride to work, this was one of the factors that influenced our decision to select the Arduino. The programming team has been working to assemble the circuit and ensure all of the components are controllable with the code, as expected, and to the level of precision necessary for the ride to accomplish the transition between the Ferris wheel and the drop tower successfully. We have also been working with the mechanical team to develop the pacing of the ride, as well as necessary safety checks.
I had the pleasure of leading the finance team in the ISU competition, and so I collaborated with members across different teams to make sure that we had all the items we needed to be successful and to make decisions with our budget and various purchases. I analyzed different costs and compared many different factors that went into our decisions, such as the cost of the Ferris wheel as compared to the drop tower. I kept track of manufacturing and assembly time, as well as 3D printing costs. I made sure that all the teams were kind of working together.
My name is John Foltz, and I'm the leader of the safety team for TEA&D's team. As part of the risk analysis, we've been working to minimize various risks that we've associated with the project that we've created. Whether it be experiencing the attraction, viewing it, or maintaining it, we've been able to identify risks that could cause potential hazards, and we've been working to minimize these hazards using the Advantage software. I've been leading our team in the Astm F24 compliance analysis. Throughout our project, we've been working to design our attraction to be compliant with F24 standards so that it meets those standards that would apply if we were to create the real-world attraction.
One final announcement.
Are we good?
Yep.
Awesome. Thank you guys for joining us for the interviews this morning. We're going to take a quick lunch break. We'll be back at 1 p.m. with some other videos. Thank you to all the teams that are participating, and thank you again for presenting it in the Zoom calls so we can all watch your guys' rides. It's very nice.
Thank you to the teams, and thank you to the judges, who you're not seeing it on the public live stream, but they are working behind the scenes doing grading and all that such. We will be back at 1 p.m. From 12 to 1. We'll be just watching the ride model stream.
Grab some Chick-fil-A with your friends.
Yeah, get some lunch.
Thank you.